we're going to get more into Lewis symbols in the next unit in chapter 2. But for now, I just want to tell you that the electrons in atoms are arranged in what we call shells. You know, different atoms have different numbers of electrons depending on the number of protons. And those electrons themselves are arranged in kind of shells. And sort of like an onion, layers of an onion. And the outer layer of electrons on an atom is called the valence shell, or the valence electrons. All right? And there was this symbolic way of representing the electrons that are in the valence shell that somebody who was a professor out in California, his name was Jan Lewis, came up with a long time ago, where you just arrange dots around the symbol of the element to indicate the number of electrons that are in what we call the valence shell. And so one dot indicates one electron in what they call an orbital, 2 dots, 2 electrons. So hydrogen just has 1 valence electron, so we would make its Lewis symbol like that. Helium has 2, doesn't matter which side you put it on, I have more space over here, I'll put it there. Nitrogen has 5 valence electrons. How do I know how many valence electrons are in these elements? Well, as it turns out, the periodic table is a guide. And again, we're going to come back to this electron configuration in the next unit, but for now, to really understand ionic compounds, you need to know one simple thing, and that is that group 1 elements have 1 valence electron, group 2 have 2 valence electrons, group 3A have 3, etc., all the way up to group 8 have 8 valence electrons. All right, and what happens is the metals in group 1, 2, and 3 tend to lose their valence electrons to form ions. So if group 1 loses 1 electron, it's going to form an ion with a +1 charge, like the example we saw with sodium. Group 2 metals are going to form ions with a +2 charge because they're going to lose their 2 valence electrons. And group 3 metals are going to lose 3 electrons. All right, the nonmetals in groups 5, 6, and 7 tend to gain electrons. All right, and so how many electrons do they gain? Well, as it turns out, this group out here are the noble gases. Noble gases have, except for helium, have 8 valence electrons. So it turns out 8 is a very stable number of valence electrons. So the nonmetals tend to gain electrons such that they'll end up with 8. So if you have 7 already, you only need to gain 1 electron. So the example we saw, chlorine tends to gain 1 electron. It would have a -1 charge when it gains 1. The group 6 are going to gain 2, so they're going to have a -2 charge. So these will form ions with a -1 charge. Group 6, -2 charge. Group 5, -3 charge. Again, I'm telling you this just so you can understand a little bit better the formation of ionic compounds. We'll come back to the details of how the electrons are arranged in the next unit. All right, so to be quick about it, you can tell the Lewis structure, you can predict the Lewis structure by finding where on the periodic table the element is, and then you can say what the valence electrons are based on the group that it's in, and then you can draw a little symbol. So oxygen is in group 6. 1, 2, 3, 4, 5, 6. So it has 6 valence electrons. Sodium is in group 1, it has 1. Chlorine's in group 7, so it has 7. Potassium is in group 1, it has 1. Magnesium is in group 2, it has 2. Okay? So you can use Lewis symbols to work out the formulas of ionic compounds, and that is on one of your worksheets that you can do in your class. There's lots of worksheets to go with this particular activity. So I don't want to take a lot of my time because I have limited time to go through this part 1 of video 9. I just want to tell you one more thing. For transition elements, they have variable valence. So in order to indicate the type of charge on those particular elements and those particular compounds, you have to use Roman numerals. And you will see examples of that as we move along. Okay, let's see, where are we? Okay, so on this periodic table, oh, I know what I was going to do. There's nothing on this periodic table, but this is a good, it's just the shape of a periodic table. To recognize that these are the noble gases, they have 8 valence electrons, all right? So they're not going to tend to form cations, anions, or bonds at all. Some of the other thing I wanted to tell you is there are two transition metals. Silver is found right here and zinc is found right here that do not have variable valence. We can predict the type of ions they're going to form, and these you just have to memorize that silver tends to form an ion with a +1 charge, zinc tends to form an ion with a +2 charge. Okay? All the other metals from group 1s, 2, and 3 you can predict. The rest of the transition metals, we'll have to use a Roman numeral to decide. And as you work through your worksheets, this will become more clear. Okay? Okay. Let's see. All right, one more thing here. All right, so when we name our ionic compounds, we name the metal using the metal name. We name the nonmetal using the nonmetal elemental name plus the IDE suffix. And then also, we do have some ionic compounds that are formed with what we call polyatomic mini-atom molecules that have a charge. So they're polyatomic ions. All right, and these are some more common polyatomic ions that you should be familiar with. All right, and what's listed is the chemical formula, the charge, and the name. For example, nitrate, NO3. The nitrogen is chemically combined to the 3 oxygens, and the whole cluster, the whole group of atoms carries a -1 charge. You just have to remember the name. I'll give you a hint, though. The polyatomic ions oftentimes end in ITE or ATE for the endings. Normally, the IDE ending is associated with an element like chloride, fluoride, bromide. Whereas bromate is a polyatomic anion. It's kind of obscure, so you don't have to memorize it. But chlorate, for example, is a polyatomic that's more common. But anyway, so the IDE normally is going to indicate that it's just a single elemental anion, like nitride, as opposed to nitrate or nitrite. There are a couple exceptions. Cyanide, hydroxide, and peroxide all also have an IDE ending. So you'll just want to kind of get this organized in your brain, because a very common mistake is people will confuse, like, for example, the nitride ion with the nitrite ion.